We have participants who have already joined us. Good morning, good afternoon, good evening to all the participants as well as to the panel members. Hope you all can see the screen and I'm audible to all of you. We have participants who have registered from different regions of the globe, and a lot of them have already joined us. They're from Europe, Asia, Indonesia, Singapore, Thailand, Bangladesh, Middle East, UAE, Turkey, and as far as Australia and even from China. So we welcome all the participants to the Plastics Flame Retardancy Learning Series number 3. We will be discussing on testing of FR characteristics. This is part 1 because since it was quite a long comprehensive area and we felt that people needed to be more aware of it because testing is very critical for engineering plastics which are used in FR applications. So we have divided it into 2 parts. So this is the part 1 which we'll be doing right now. The webinar is important to all the practicing professionals in electrical, electronics, automotive, especially now with the trends in electrical vehicles, appliances, and also for the emerging markets where we talk about a lot of automation. So we can see that FR is critical for artificial intelligence as well as robotics. This presentation is very important to those associated with design, selection, processing, testing, application of various materials. Yeah, next. The webinar is done jointly by Formulated Polymers Limited and Eurostar Engineering Plastics. The total duration of the webinar would be around 45 minutes, 40 minutes for the presentation and 5 minutes for the question and answer. We would request all the participants to post your questions in the Q&A box and not in the chat box. This webinar is more practical and not theory based. So it's based upon our experience of the last, I think Eurostar has more than 40 years experience. FPL has also 27 plus years of experience. So we have already completed series 1 as well as series 2. I am the moderator. My name is Rashmi Bhardwaj and I am Vice President Development in Formulated Polymers. This was the flyer which we had forwarded to all the members. So now after completing series 1 and series 2, series 1 we discussed the history, need, ISO classification of FR chemistry. Shekhar and Alexi both had given presentations and it was in so much high demand that we had to do a repeat series for that. And series 2 where we discussed on the FR mechanism and selection criteria. Testing part 1 we are doing right now. Testing part 2 is scheduled for the 24th of this month. And then we will also be covering up various standards, processing, the design perspectives. We have a total of around 12 series which have been planned by us. And next slide, Shobna. Yeah, next. So some of the industry professionals have already agreed to present some of these series. We request many more of the industry experts and professionals to come forward and share their learnings and experience so we can incorporate and have a more comprehensive discussion which will be useful across the board at different locations. Since Eurostar Europe and FPL Asia, they both specialize in engineering plastics. Most of the examples are based on polyamides, both polyamide 6, 6,6, 4,6, etc., polyamide 12, and ABS as well as polypropylene. I would like to receive panel members. Shekhar is there, is the director for Formulated Polymers. We also have Rasim Gibbs, who is the technology and marketing director for Eurostar. Then we have the speakers, Mr. Krishnamurthy, who is general manager operations, Formulated Polymers. He has a master's in science and over 29 plus years of experience in plastics. He has worked hands-on and right from design, development, quality assurance, compounding. He has a very versatile experience, and he has developed in his career more than 300 new products in the electrical and electronic segment, as well as for the automotive segment. He will be handling in detail the UL 94 flammability tests. The second speaker, Alexei Chopin, technology manager from Eurostar Engineering Plastics. Alexei has a master's in engineering from ITech Lyon. He has 25 plus years of experience in formulation, compounding, application development, worked quite comprehensively, extensively in the electrical and electronic segments. He's a co-applicant to many patents in FR engineering plastics and as a specialist in low voltage and medium voltage control, FR design, and he will be discussing on glow wire test in detail. These are the two tests which we identified, and we find it critical as far as flammability applications are concerned. They're also correlated with application testing. So that's the reason why we are going to be covering these in much more detail. We have done series 1, so I'll do a quick recap of the series 1. Fire accidents are due to the plastic usage, and that has led to the extensive use of flame retardants in plastics. So the entire evolution Shekhar has discussed the reasons why we are using plastics and how it has evolved over the years, right from thermosets to thermoplastics like PVC, and now to the engineering plastics. For all those who have missed out on the first presentation, we have the YouTube link and all of you can attend that. Alexei in that same presentation has discussed ISO 1043 and gone into details regarding what is the codification in terms of the polymer which is used, the fillers which are used, the plasticizers, and the flame retardants. We also did the series 2, which was on the flame retardant mechanism and the selection criteria. We discussed on endothermic reactions, radical quenching, and thermal shielding processes. We also in detail, we discussed on the halogenated nitrogen, organic and inorganic phosphorus compounds. We also had a discussion on metal oxides, hydroxides, salts, boron and zinc compounds, silica compounds, and in specialty we went into polyvinyl alcohol. So we discussed almost all the flame retardants which are being used globally, and the reason why we use it, why one flame retardant is preferred over the other. The trend is towards more environmentally friendly compatible FRs, and this is mainly driven by the NGOs and the OEMs. So legislations like ROHS, REACH, and government legislations for each country are becoming more and more critical, and due to this, we have also comprehensively decided on the selection criteria. Here we have the previous webinar on the YouTube link. The link is attached over here. Now I would hand over the presentation to Krishna. We will be discussing on the testing of FR characteristics part 1, UL 94. He will be going into details. Krishnamurthy, you can take over, please.
Thank you, Rashmi, for my introduction and brief recall of previous webinar topics. Hope I am audible. Good afternoon, good morning, and good evening to all participants of today's webinar. In previous webinar series, we discussed about how plastics converted into FR plastics and various types of FR formulations. Formulation and product ready, but it needs to be tested and validated before going to market. All pros and cons of product formulations need to be found before going as an end product. Testing is essential to find good and weakness of product. So in today's discussion, we are discussing about testing a part of FR materials. Slide shows various types of tests to measure flammability characteristics of materials. In UL 9.4, we have variety of tests like horizontal burning, vertical burning. In vertical burning, we have series of tests V0, V1, V2. It tells the burning characteristics of material. In IEC standard, we have glow air flammability test. It has two types of tests, GWIT and GWFI. Also, we have comparative tracking index, auto air ignition temperature, high current arc ignition test, HAI. These tests determines the ignition characteristics of plastics. Also, we have a variety of tests like smoke test, LOA limit oxidation index. Then we have long-term property UL 746B, short-term property evaluation UL 746A, and end product evaluation UL 746A. So the list is big. We will pick. List is big. We will pick two properties today for a discussion. Now we are going to discuss UL 9.4, which is test for flammability of plastic materials for parts in devices and appliances. Before going into that part, why we need to follow UL test method? This question arising in our mind. Reasons are UL is independent certified body of standard for safety, started in 1894, almost more than 125 years experience now. Previously, raw material and end products were tested separately and reported as accepted or rejected. But UL changed this approach and it tested raw material performance in end product and reported. UL uniquely positioned to provide complete view of how product function within the given system, which is particularly critical for plastic and component industry. It helps to ensure safety for both users and manufacturers. End product less prone to malfunction. It minimizes replacement cost. So industry overwhelmingly accept test methods. Slide shows various types of tests under UL 9.4. Start with horizontal burning, HB test, particularly for automotive parts, and HBF, HBF1 and HBF2 for foam-like materials. Then in vertical test, we have V0, V1 and V2, majorly for E&E parts, and VTM0, VTM1, VTM2 for thin flames application. Also, we have 5VA, 5VB for high concern areas. This series of tests can help to determine how products will react when exposed to flames. Now we move on to test apparatus requirement and setup procedures. We need to confirm testing equipment or apparatus condition before going to any test. First, we start with specimen. Test specimen should have some standard dimensions. You will prescribe the length and width and thickness of the specimen. For HP and V0 vertical burning, we have to follow length of the specimen 125 and width should be around 30 mm. We have some tolerance of 0.5 mm. Then thickness of the specimen is also important. It should be around 3 mm for horizontal burning, and in vertical burning case, it should start from 0.025 and it should be around 13 mm. So the maximum thickness should be 13 mm for all UL 9.4 test. Then next important lab equipment, burner. It is heat source. The laboratory burner tube side should be maintained as per dimension given on slide. It should be 100 plus or minus 10 mm. Burner should comply with ASTM D5025. Then burner mounting fixtures are having some standard dimension. It requires to mount some 20 degrees angle for some of the tests like 5VA and 5VB. Then in next important one is flame height. Test flame should be set 500 watts nominal using test method ASTM 5207. Then we have to use methane gas of 98% pure. Then the flame height should be 20 mm and it should be blue and yellow tape at the bottom. The next one is cotton bed. 100% absorbent cotton underneath at 300 mm from the tip flame tip. And finally, for any ASTM, any IEC standard test method, the specimen should be conditioned before going for the test. In this case, the specimen should be annealed at 23 degrees C at 50% RH using desiccator. If it is in oven condition, it should be 70 degree plus or minus 2. Then now we move on to horizontal burning test. In horizontal burning test, the specimen clamped in horizontal position. HB test widely followed in our auto industry. It tells the rate of burning of plastic material used. It helps auto industry in a big way. Rate of burning of material helps to calculate escape time for passengers in vehicles. HP rating normally requires for decorative item, attended household items, air dryer, etc. It applicable for all prospects irrespective of flame retardant or non-flame retardants. Then we go, the slide showed SP test procedure in details. Here in the slide you can see specimen of length 125 mm and width 30 mm positioned in a clamp. Ignite the specimen using burner with blue flame. The ignition time should be 30 seconds. After specimen reaches 25 mm, we need to start the clock and find burning rate. Then the acceptance criteria for this test, standard requires burning rate for 40 mm per minute for a thickness of 3 mm and more. For less than 3 mm, we require 75 mm per minute. Then fire should switch off before 100 mm mark. And other HP tests like HBF, HB1 and HBF procedures and test conditions are similar. Only we have to change the specimen like foam-like materials. Then now we move on to vertical burning test. In vertical burning test, we have 3 types of tests: UL9, V0, V1 and V2. Now we start with V0. The V rating requires for high concern areas of non-attended household items like TV, directly supporting live electrical parts like switches, enclosures, etc. Then in the slide you can see the specimen of length 125 mm with 13 mm clamped vertically in the stand. Thickness of the specimen varies from 0.05 to 30 mm, but the normal using thickness will be around 0.4 mm, 0.8 mm, 1.6 mm, and 3 mm. Ignite the specimen using burner of blue flame 20 mm for 10 seconds. Measure the self-extinguishing time and record. Then again we have to flame the same specimen for another 10 seconds and repeat the procedure. For a batch, we need to apply 10 flames, 2 flames per specimen, totally 5 specimens we need to be tested. Acceptance criteria, total glowing time of 10 flame should not be exceed 50 seconds in V0 case. Then individual specimen glowing time should not exceed 10 seconds for first flame and it should be within 30 seconds for a second flame. No ignition of cotton bed underneath allowed for V0 rating. Specimen should not be burned up to clamp. That means you should not burn more than 100 mm. Variety of products are available in foam poly and star flame ranges meeting B0 ratings. We can see the list. We have foam poly PP, FR, V0 in polypropylene range meeting V0 rating. Then in ABS we have ABS, FR, V0. Then in nylon unfilled we have foam poly N6 GP28 FR. Then in filled glass filled glaze we have N6 GF30 FR 30%, nylon 6. Then we have in polyamide 66 we have 28% glass fiber filled. Then in star flame range we have AFR 450X2. Then we have P110ZE to meeting vertical burning V0. Then we move on to vertical burning UL94 V1 and V2 test procedure. The test condition, specimen dimensions, test procedures are same as per previous test V0. Only acceptance criteria alone vary in V1 and V2. Total glow time of 10 flames should not exceed 250 seconds as against 50 seconds in V0 rating. Burning time of individual specimen for first flame should not be more than 30 seconds, and in second flame it should not be more than 60 seconds. The only difference between V1 and V2 will be cotton bed underneath should not be ignited in the case of V1, but it is allowed in the case of V2. Then in V2 range, we have a variety of products in both star flame and foam poly ranges. We have star flame TK0052E, it is 25% glass filled. Flame retardant V2, then we have 20% glass filled BZ0040E. Then we in foam poly range, we have 20% glass filled, we have 20% mineral filled retardant, then we have 25% mineral and glass filled meeting V2 rating. And finally, we move on to 5VA, 5VB test details. Normally, this type of rating required for highest concern areas like enclosures in stationary or fixed electrical live equipments. 5VA, 5VB test need to be conducted both bar as well as plate specimens. Bar specimen dimensions are 125 mm, 30 mm width as like previous HB and vertical testing. But plate specimen, it should have a 150 mm, depends upon thickness of the part. For 5VA, 5VB test, gas flow rate varies to maintain flame height of 125 mm and inside blue tip should be 40 mm. The test procedure, apply flame for 5 seconds, remove and wait for 5 seconds. Again, repeat the same for 5 times. Acceptance criteria, total flame time of 5 attempts should not exceed 60 seconds. No debris found in the cotton bed underneath. No hole formation should occur for 5VA classification, but hole formation accepted in the case of 5VB classifications. Then now we discuss about influencing factor of UL94 test. The slide show various parameters which will directly influencing the test results of UL94. Thickness will be more important one. Burning behavior varies with thickness of the part. That is why UL in UL yellow card gives flammability properties with respect to thickness. Also density of the material, flow, color, and any anisotropy of material molding condition are also influences UL94 test. Now we move on to demo video of UL94 V0 V2 test. This video taken at Formulated Polymers Limited India and Eurostar Engineering Plastic France labs. For any laboratory test, we need to start with safety aspects. UL94 test deal with high heat, molten parts, fumes and flames. So lab persons who assign this type of test need to wear proper safety equipment before going for a test. Next part, apparatus required for test. To do UL94 vertical burning test, we need a laboratory fume hood with proper exhaust facilities, then specimen holder, then Bunsen burner with wire at required length. Then we need methane gas supply of 98% pure. Then we have 100% absorbent cotton bed, then ignition source, then we need measuring scale, then timing device of accuracy 0.1 seconds. Of course, specimen and specimen need to be annealed using desiccator. Then finally, we need a PPE of gloves and goggles. And in next part, equipment setup, specimen length, width and thickness need to be measured and recorded. Then it should be positioned in the fixture at vertical angle. Then cotton bed underneath to be at 300 mm length. Then flame height should be fixed exactly at 20 mm by adjusting the gas flow rate. We are seeing the UL94V0 test, which is now performed using foam poly N66 GF25 FRP material. Test specimen positioned vertically in the holder. Specimen ignited using burner for 10 seconds. Withdraw the flame, count afterglow time and record. Flame the same specimen again for 10 seconds, then record afterglow time. This procedure repeats for 5 sets of specimen. Then we move on to UL94V2 test performed with star flame T1000Z222. Procedure condition are same as we seen in earlier video. Specimen ignited for 10 seconds and withdraw. Then again we ignite the same specimen for another 10 seconds. Then we need to record the dripping and cotton ignition condition. Then based on by referring lab observations and above acceptance criteria shown in the table, we can easily rating tested materials flammability. That's all from UL94 test. I handed over the session to Roshmi for next program. Thanks to all. Bye.
Thank you, Krishnamurthy, for elaborating each and every aspect of the testing for UL94, whether it was V0, V1, V2, HB, 5EA, 5EB, and you gave examples also. So I think it was very comprehensive. I understood it very well. So I presume all the participants would also have understood it. Now I would hand over the presentation to Alexi. He will be covering up in detail the glow wire test, which is also another critical test for flammability. Alexi, please. You are able to share the screen?
Not yet. I don't know if you can hear me, but I'm still on mute.
Yeah, we can hear you.
Okay, that's the first step. Then I have to share my screen. It seems it's. Can you see my screen?
No, we can't see your screen. Should
And
I ask Shobna to continue? Because I have the same problem, so I had asked her to continue.
yeah, you can. Yes, of course. I can work remotely. It's no problem.
Yeah, just see if you can share it just now, because she's changed the rights, host rights she has given to you.
Yes. Can I share my screen?
Yeah.
We still have an error message on the screen. It's a pity.
Not shared. I'll ask her to share her.
Yes, very sorry, but yeah,
I
move the
also
pages
had the
for
same
me.
problem. In the trial run, it was okay. I don't know what happened right now.
Yeah, I don't know why. So if someone can share a screen, I can comment the screen.
Yeah,
it's no problem.
Yeah, we're just sharing it. I think it's very critical that we have everyone understand whether it's with respect to our products or with respect to customers' applications. These tests are very critical for flammability. And more environmental regulations coming in, more and more awareness is creating a need for understanding these with respect to applications. So I think, yeah, so now.
Can you see my screen now? Because
Yeah,
it's
we can see your screen. Only you will have to do a slideshow.
Yeah, I would love to, but I see that I don't have the ends. But is it okay now?
Yeah, now it's okay.
Cool, we are there.
Yeah.
So very sorry for that. But we are in kind of remote location on the other side of the ocean. So maybe some electrons got lost somewhere. So today I will talk about glow wire testing. So it's another flammability test, as Christian Murphy explained. So it's a different test measuring almost the same thing, but in the case of UL, we are dealing with an open fire, meaning a flame which is applied to the plastics. And in the case of glow wire test, we are creating the overheat to create the flame. So this test, to be honest, was fundamental in Europe and is increasingly in use in Asia. Well, it was not in use in US and tends to change. It tends to change because, of course, parts are produced now everywhere and tend to go worldwide in every location. But until very recent times, when a customer was designing a part, if it was for Europe and Asia, it was created to comply with the glow wire test standard. And if it has to be imported in the US, then it has to comply with UL. And it was perceived, UL was perceived, at least in Europe, as a custom duty almost for plastic. So glow wire test is a kind of different philosophy. We are not, we are creating the overheating. Why? Because it's intended mainly for electrical parts. And the picture is a good one here. You see an overheating component by an overload, and this overload creates, not in all cases a flame, but an overheating that will ignite the plastics. So it's true for electrical cabinets. It's very true for wires, because they can overheat. And of course, it makes sense if there is an open fire. So glow wire test is used for parts, assemblies of parts, or individual components. So the test is quite simple. I don't know if I can remove this, but okay. For example, the principle is very simple. You have a hot rod, which is heated to a high heat temperature, almost turned to red, which is applied to a plastic spot. And what we will see is the interaction between this wire and the plastics. So what are the criteria of a test passing is when the wire is applied to the plastic, the specimen does not constitute an ignition risk to the environment. The flame should not last more than 30 seconds. And of course, we will see if the flame is propagated to the surrounding. So the assessment criteria is maximum penetration depth is 7 millimeter. So this is mainly due to the shape of the needle, let's say, of the rod. You see there is a parallel rod, which is not so long, which is 1 centimeter. So it has to be tested in the parallel area. The force is 1 Newton. It's made by design of the apparatus. Application time is 30 seconds. Burning or glow wire time is below 30 seconds. And to avoid propagation, paper or wood has to be undamaged. Then basically, so the glow wire test, you have 2 different families of tests you can conduct that but measure 2 different things. The glow wire flammability index, so-called GWFI. It's a test where you apply this wire against the plastics for 30 seconds and you see the reaction of the plastics. If it goes on burning, if it stops burning, if it's propagates the flame. The glow wire ignition temperature, so-called GWIT, is different in its operation in principle. You apply the wire to the plastics and you see if there is a flame, meaning that you are not looking at the burning behavior of the material, but the ignitability of the material. This is why it's called the ignition temperature. So basically, GWFI is the highest temperature at which the flaming, glowing the specimen extinguished within 30 seconds after the removal of glow wire coals without burning and propagating the flame. The glow wire ignition temperature is the highest temperature, but does not lead to ignition. But when you see, when you take about glow wire test, you have glow wire test, glow wire flammability index, and glow wire ignition temperature. The difference is that when you see in the standard, it ends with 11, the test is run on part. This is a glow wire test. When the test is run on sample, it can be a glow wire flammability index or ignition temperature. For conditioning is the same as KK explained before for UL. It needs to be conditioned, of course, because some materials, especially some polyamide, are picking up moisture. And you can imagine that a material which picked up too much moisture will be less sensitive to fire. Temperature of glow wire. For glow wire test, they are very precise temperature from 550 to 960. You may ask why those temperatures. I think the 960 is very self-explaining because it's very difficult to calibrate those wires, and 960 is the exact temperature of melting of silver, meaning that when you calibrate the glow wire test, you put a teeny part of silver foil on the wire, and you see when it melts. And 960 being a sharp melting point for silver, it helps to calibrate the wire. So it's been 960 the standard for many years, but of course it's very stringent. And now there are temperature in between for different applications. The pressing force is 1 Newton. It's design related. You cannot avoid it. And application flame is 30 seconds. The rate of approach and withdrawal of the wire is important, especially for GWIT, the ignition temperature, because if you have a shock or if you are going too fast or too slow, you can change the measurement. This is why now modern apparatus are automated. You don't have control on this one. Okay, the influencing factor. So here you see the test we have in FOS. You see the wire, which is very heated. It should be 960 because around 850 is red, but around 950 is almost white or very yellow. So, principle, this sample holder is moving toward the rod, the burner, and you are measuring the interaction. Influencing factor are specimen thickness. This is especially true for blow wire flammability index, because the needle, the wire, goes through the plates. And the time to go through the plates is the time that the wire heated material. It's less important for GWIT, the ignition temperature, which is more a surface-related measurement, because you are measuring the interaction between the fire and the plastics. Apply load is fixed, you cannot change it, and testing method can be a manual or automatic. It is very important for an unattended device. What is an unattended device? It's basically what we call the white goods, or material or part that you cannot really have an eye on it. For appliance, is mainly, for example, washing machine. When you wash your stuff, you are not sitting beside the machine to see if it works fine. You are in another room, you are in another place. By opposition to attended device, these are devices that you have in hands or you have under the eyes, and if there is a failure, you can easily unplug, or you can easily remove the plastics from the wire. Important in those applications is the intensity, which is related to, and the limit is around 0.2 amperes. Above 0.2 amperes, you say that it's quite a high current, and below 0.2 ampere is more a common signal. And the risk of flammability, simply due to the Joule effect, is less. So this IEC 6335 is really applied to household appliances, and it's where we have more of a request, and which is the more stringent test. So you need to pass the GWIT at 775. This is ignition temperature, flammability index 850, ball pressure test, which is a kind of thermal measurement of material resistance, flammability, as KK explained, most of the time V0 is needed at 0.8. Tracking index is more related to the electrical resistance of a material. Once more, this standard is very limited to household appliances, but nonetheless, people even in automotive are looking at this test, because for them it's sometimes more representative than UL for a failure, because in this case there is no open fire, there is an overheated component by an overload. There is a bunch of sector which do not apply. For example, video is another standard, medical purpose is another standard, handheld is the easiest one because you can have a control on it, and computers are really related to other standards. Nonetheless, it tends to be a very now universal measurement, this glow wire flammability index. I won't go too much into detail because time is flying by, but basically, if you are designing an apparatus, two things are very important. Is plastics at more or less than 3 millimeter of the lighting part? Lighting part is the part which is in contact with it, direct contact, conduct current but can overheat. If yes, then you have to follow this flow chart. If no, then you have to have another question. Do my material carry more than 0.2 amperes? Yes or no? If it's above 0.2 ampere, then no way, you have to survive glow wire flammability index at 850 and to pass a test on part at 750. And then you are there. If the material is below 0.2 amperes, the same thing, it's an easiest test, you are to comply 650 glow wire, or you have a GWIT of 675. In case of below 0.2 amperes, it's quite simple. We will take a bit more time on this slide with material having a more energy, meaning more than 0.2 ampere. So you have two routes. Or you can make certification on testing, on samples, or you can make on pot. If your material has a certificate GWFI 850 and a GWFI or 775 on samples, your demand is fulfilled. But you can test on part. In this case, you test at GWIT 850. If test is passed and you have a certificate, you're done. Then, if you don't have a certificate, you can test on part, and if it passes with ignition, you are done. In the case you cannot survive a test on 750, then you have another route where you can pass so-called needle flame test. So needle flame test is a simplification of a UL test. The flame is very tiny, and you are applying for 30 seconds. But basically, it's almost a burning test. And another way would be to make sure that all the surrounding parts are minimum UL 94V1. Let's go now into real things. So the glow wire test, I'm launching the video. On this one, you see it's 750 degrees C. You see the wire automatically is applied to the part. Then the part touches the material heats by conductivity. It's now overheating. You see the material is almost not burning, but charring. And in this case, it's quite well done because the charring takes place, the material fumes, but you cannot see the flame. To pass the test, you need to have a flame below 3 to 5 seconds. And in this case, there is no flame at all. So at the end of the 30 seconds, the wire is removed. And in this case, it really passed the test. Oh, sorry. Then you will see a test made in FPL India on their apparatus. So here the same, they are launching the test. The wire is applied to the plastic spot. You see immediately, then the wire is very hot. Huh? You see it's almost white, so it's 960 degrees C. And of course, at this temperature, polymer burns. You see the flame is formed. In this case, you see there is no flammable drips, which is a good sign. And after 30 seconds, the wire will automatically removed from a sample. And you will see in this case that some material is carried in the nozzle of the flame, but immediately, almost immediately, the material is extinguished. So in this case, the test is really nicely passed. So of course, we don't have a material that fulfills everything and in every situation, but we are quite proud to say that within FPL and Eurostar, we have a solution for almost everything. It's just a matter of selection, a matter of choice. And as glow wire do not compare with UL, you know, a material that passes UL 94, even a V0 at 0.8 can fail glow wire, and a material that passes glow wire can fail UL because there are different types. But nonetheless, within our range, we really have a solution for all. So I won't go into detail on this one, but the range is really, let's say, covered. And we have a solution for unfilled material, for filled material, for reinforced material. We have material which are designed specially for glow wire, which are very cost effective. We are material that are designed to comply with UL. And let's say there is really a huge choice. I've been too long as usual, so maybe I will on back to Rashmi if you have questions.
Yeah, thanks, Alexei. I think this was quite comprehensive.